A couple of you had difficulty doing the equilibrium question from the 2020 Examcraft mock, I see from correcting them. So I said I'd just make a really quick video to show you how to do it. So the question reads here, write the equilibrium constant for the above expression. We know how to do that. Then it says part D. Okay, so that's what I'm going to do out. In an experiment, 4.5 moles of nitrogen, okay, and 13.5 moles of hydrogen were mixed in a 2-litre container. So I'm always going to ask you to write the following headings. So initially, first of all, then at equilibrium, and then lastly, concentration at equilibrium. Okay, for concentration at equilibrium, it's always going to be the volume. It's going to be the molarity divided by the volume, which is always given in litres. Straight away, this vessel is a 2-litre container, so I'm going to just leave that somewhere to the side to remind myself to use it in the calculation. Now, first of all, we are told 4.5 moles of nitrogen and 13.5 moles of hydrogen were reacted in a container. That means initially I had not any of my product produced. The question then says, it was found that there were 3 moles of ammonia in the equilibrium mixture. Calculate the concentration of each gas at equilibrium in moles per litre. So that means there were 3 moles of ammonia in the equilibrium mixture once equilibrium was reached. This is ammonia here, NH3. What I'm going to do then is use a different colour pen to put in my value of X. So the X value I'm going to put in is directly related to the coefficient of each of the molecules in the balanced chemical equation. First of all, here I can see I had 1 nitrogen, so as equilibrium is occurring, I'm decreasing by 1x amount. Here I have 3 hydrogens, so as equilibrium is occurring, 13.5 is decreasing by minus 3x amount. Here I have 2 ammonias, so I started off with no ammonia. I'm now going to increase by 2x amount. Okay, the only way I'm going to be able to move any further with this equation is if I identify a link going forward, and the only link I have is here because this is the most information I have. So I started off with no ammonia. After 2x amount was added to the vessel, I now have 3 moles of ammonia. So very simply put, 2x is equal to 3. X by itself then is very clearly 1.5, or if I had 3x, I could say I have 4.5. So I'm going to use this little side piece of information as a key. I started off with 4.5 moles of nitrogen and I decreased by X amount. That's the same as saying 4.5 minus 1.5, which means that at equilibrium I'm left with 3 moles of nitrogen. I started off with 13.5 moles of hydrogen and I've decreased by 3x amount, which is 4.5. So at equilibrium, I now have 9 moles of hydrogen, and 3 moles was given to me in the question. I now have molar quantity for each of the 3 species in the system at equilibrium. I now need to find out the concentration by not forgetting about my volume in litres that I had at the beginning. So 3 divided by my 2-litre container will give me a volume of concentration of 1.5 moles. 9 divided by the volume 2.5 will give me a concentration of 4.5 moles. And 3 divided by 2 again will give me 1.5 moles. If I'm writing out Kc for this reaction, which I'm going to do down here, it's always going to be what's on the right hand side divided by what's on the left. So dare I say it, products over reactants. We know that the terms products and reactants don't really stand true in equilibrium because the actual system itself is reversible at any moment in time. But ammonia is on the right hand side here, so in a square bracket I'm going to put ammonia. Why do I put a square bracket? Square brackets indicate concentration in moles per litre. Now, I don't have just 1 ammonia produced, I have 2 of them. So it's ammonia, which is the molecular formula, goes inside the bracket, and the coefficient 2 now becomes the power of 2. This is all divided by the substances on the left hand side. So on the left hand side here, in a square bracket, I have nitrogen. Nitrogen's coefficient is 1, so you can put 1 up here, or you can just leave it with nothing. It's the same thing. and then I have 3 hydrogens. So hydrogen goes inside the bracket to the coefficient 3 now becomes a power like so. So what I'm now going to do is exactly sub in that Kc value, but instead of using the molecular formulas, I'm going to use the molar quantities at equilibrium. So ammonia on top, I have 1.5 squared. All divided by nitrogen at the bottom, I have 1.5. All multiplied by hydrogen, I have 4.5, and that's to the power of 3. Now, when you pop all that into a calculator, you get a value of 0.01646, and my unit here, okay, the square is going to cancel with, say, 2 of those, so I still end up with moles to the -1. And that's it.